which we require while writing the programs in 8086. Before writing the actual program, before defining the different types of assembler directives, we should understand that the format or the general pattern for writing assembly language program in MASM, one of the assembler for 8086. In 8086, MASM can be this sort of pattern. In 8086, first of all we initialize page directive, and then we write title directive, and then we write memory model definition directive, then segment directive, proc directive, and number of procedures or the assembly language codes, and then in the proc directive with the in directive, and overall program is ended, and in this way this is the general pattern. And the directive which you see here, I'll be discussing in this tutorial. And there are different types of directives: page directive, title directive, memory model definition directive, segment directive, proc directive. These all are much useful while writing the programs in 8086. The basic format of assembly language program based on this above pattern can be like this. Suppose this normally the page and title are the optional directive, and we may not write this as well in the program. So if we write, then also that's fine. And on the page directive, we may define like this: page 60, 80, 60. We'll be discussing this about different types of directive later. And title directive, title to define the title of the program, and then memory model definition, how much memory the program needs to occupy. Normally 8086 has 1 MB of internal memory, and it supports 1 MB of memory, and among that 1 MB memory, how much memory our program needs, that we should define this memory model definition. And then stack, for stack purpose, how much memory we should define. This should be defined in this stack directive, and data directive, data variables are defined in this directive, under this directive. And the code directive is used to define the main part of the instruction. 8086 assembly language programs in main assembly language program. In this part we write under code and starting the procedure, and we'll end the procedure and overall program in this way. This is the general pattern, basic format of the program. We'll be writing later this overall program using these assembler directives. And I'm discussing about the assembler directives, and I explain about this simple explanation about this and what are the different types of directives. So we'll go through what is actually the directive. Normally the assembly language supports a number of statements. There are different types of statements, keywords in 8086. So among these are directives are also one type of statements, and that enable to control the way in which the source program assembles, how the assembler should function, and list different types of machine codes are defined by this directive. Overall, in this way we can say that assembly language supports a number of statements that enables to control the way source program assembles, means how the assembler should actually assemble and list the required in the program. These all statements which direct the assembler to dissolve functions to perform dissolve functions are defined by assembler directives. Normally, the assembler directives act only during the assembly of a program, and actually they are known as pseudo instructions, and they look like instructions. They look like instructions in the program, instructions, but actually they are not converted into machine code. Like data stack is not converted into hex code or machine code, but only like these different types of functions, move instructions, move x, box, add AR, PR. These are only converted into hex code, but these assembly directives are not converted into hex code. This is the basic definition of assembler directive, and the main task, as I discussed in this point, that is the main task of the assembler directive is to inform the assembler or the start in the first segment. Segment refers to different code data stack segments or extra segment, or where to start, how much memory to occupy. These all are discussed, or these all are pointed, defined using assembler directives, and different types of procedures, where the procedures is start and where the overall program is started and ended in this way, and more about how much memory to occupy for data storage, code, and stack. These all are defined by assembler directives. Thus, I already told that these are also called pseudo instructions because they seem like instructions, but actually they are not converted into machine language. That's it about the definition of directives or assembler directives. Now there are different types of assembler directives used in 8086 programs. The important assembler directives are page directive. Page directive is normally the optional directive, and if we don't write this page directive, and then also the program assembler while executing the program separates the desired by default page. Normally the default page value is 5080, page 5080. This is one parameter for writing page directive. And page 50 refers to the length. Length means the number of horizontal pixels, and 80 refers to the width, and this means vertical number of pixels width for defining the page. And other important directive, which you may write in the program is the title directive. This is also optional directive, and its format is like this: title, program to print actual number. So we may write any title as per the program is written in this title directive. This is also optional directive. We may not write in the program actually. Other optional directive is on the dosseg. Dosseg stands dosseg functions for setting the segments, code data and stack segments using 8086 in the standard order. Means we can use different segments in the program after defining dosseg. This is also directive, and by default it sets these segments. Assembler sets these segments in standard order. And some of the compulsory, these are dosseg, title, page are all optional directive, but other compulsory directives are over there which we should write in the program so that assembler can execute that program and give us the result of the program. One of the important directive which is the compulsory one is that segment directive. Segment directive defines the start of the segment, where the segment has started to store data or code or stack in the program, and this is defined by the segment directive. There are different types of segment directive, and normally the segment directive are defined using the dot operator before writing the segment operator. Segment directive like stack is one of the segment directive. Stack directive, dot stack directive, more importantly dot stack directive, dot data directive, dot should not be left, because is if there is no dot, then assembler does not understand it is as segment directive. Thus in segment directive, under segment directive there are different types of directives like stack directive. Stack directive is used to define the assembler that how much memory is set aside for the stack segment. So stack directive is one of the compulsory and important directive used in every assembly language programs that is written for the mechanism of different assemblers to be executed. And other important segment is data segment. Data segment defines the different data variables. Also, after writing the data assembler directive, we can define different types of data variables, initialize different types of data variables. Suppose data in number 1 we desire to give 40 years. Then under data definition directive, we need to define the data directive. We need to define the numbers. And under code, this .code directive defines the code segment. And in under .code directive, we can define different types of procedures and actual assembly language codes that need to be executed in the program to perform some function. Normally the default size of stack segment is 1024 bytes. If you write only dot stack, then it occupies 1024 bytes for a stack, but we can also define stack 100 bytes for storing 100 bytes, for occupying 100 bytes for using a stack. In this way, this is all about different types of segment directives. And now other important directive which we should compulsorily write in the assembly language program is this memory model definition. And this is the dot model assembler directive. Dot model has the format like this: dot model and model name. Model name may be tiny, small, medium, compact, large, huge, and these are all different types of memory models. And tiny, dot model tin refers that data code in stack segment must fit in one segment of size less than 60 bytes. Means data code in stack segment all should store their data code and stack data in within the 64 kilobyte of 1 MB total memory. And other memory model definition, the small directive defines that model small defines that the code segment, one of the code segment can have size of less than 64 kilobyte, data segment of size less than 64 kilobyte. Similar, the medium dot model medium defines that a data segment, one of the data segment can have size of less than 64 kilobyte, and code segment, any number of code segment except 64 kilobyte and not more than 1 MB. Other that if we write that model compact, then it occupies less than 64 kilobyte for one of the code segment. Here is for medium data segment and for compact code segment, and in this way data segment can be occupied any amount of data segment but not more than 1 MB minus 64 KB. And if you write that model large, then there any number of code and data segments can be occupied for the program, but the total memory should not exceed 1 MB. And for huge, that model huge, if you write that model huge, and then any number of code and data segments, the same function of this large huge, and normally the total memory of supported by 8086 microprocessor is 1 MB of memory, and within 1 MB the code, data and stack segments can be placed at anywhere. So among that in that memory pool, where how much memory should be defined for data, the code or stack can be defined by using memory model definition. So this all about memory model definition. The other important directive we'll be using in the program, in every assembly language program using 8086, the proc directive. Normally the proc directive defines procedure or proc directive. Here we should write proc is the keyword used for writing procedure directive, and here the proc directive, before writing proc directive should write the procedure name, and every proc directive is ended with the and p directive, and p keyword, and the procedure should end with the same word what was used to start the procedure, like procedure name and proc, and before np the same procedure name. In this way, this is other important assembly assembler directive using 8086. After this, the other important directive that terminates the program or in the overall program, and the overall program is end directive. As we already mentioned that end p directive indicates the end of the procedure, but end directive and the entire program appears as the last of the statement. This is the important directive, and we should write this. Without writing this, the program may show some error in this way, and any one of the procedure name we may write in this. This is other important and directive. And other different types of directives are used in 8086, and other is processor directive. We may define .286, .386, .486, .586 directives according to our processor used to execute the programs within 8086 program. 8086 this directive may appear before the code segment, and this is not normally popularly used, but and directive proc directive, and memory model definition directive, segment directive are more popularly used, which we'll see later while writing the program. And another important directive we'll be using is EQU directive. It is used for redefining symbolic names. For example, and this suppose we write data x db. db means some data will be defined, data byte, and suppose data x has 25 and data eq data x, where this eq directive replaces the value of data x for data. That means after executing this line of code, data will have value the same as that of data x, which is 25. The other important directive we'll be using in every program is the startup and exit directive. Startup directive is used after the proc directive in the program to start the main assembly language program and instructions, and we terminate the program and the set of instructions by using the exit directive, which will be using in our program. Normally the start of directive starts the different types of dot directives, and exit directives completes the these instructions. And data definition directive, the important directive is data definition directive, which you should understand much clearly while defining data in our program. And data definition directive, there are different types of data definition directive. First, suppose if you want to define the number 8-bit number in our program, suppose during addition or multiplication, 8-bit to 8-bit addition, then we'll be using this for 8-bit data db directive. Number one is the variable and db is the data byte directive. This is 8-bit data and this is another 8-bit data. Normally the strings are defined as the array of data bytes. X is stored in one of the memory is 8-bit, taking 8-bit data is 8-bit data, E in another memory, L in another memory, and this way strings are normally defined as data bytes. This is the memory model definition. And if we need to define 16-bit or 2 bytes of data, then we should write num1 dw1234 or something like that. Here we are defining dw1234 4567. This is 16-bit of data. And other if we want to define 4 bytes of memory, 4 bytes means 32-bit of data, 4 bytes 32-bit of data, then we should write td 1234567 or like that. And if we write forward, then we should write d of 8 bytes, this is for 6 bytes, this is for 8 byte, dq 10 bytes, dt. In this way we can define. And we use db and dw in most programs. And other important directive is dup operator. dup operator is used to duplicate the memory locations with the defined value, like this. If we write data x db 5 dup 12, then 5 bytes containing x 0c 12 means it's converting to x, and 0c 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 in 5 bytes, arbitrary 5 bytes in arbitrary 5 memory locations. By default it stores 0c 0c 0c. And if we write this other example, data db 10 DUP what, then this occupies some 10 bytes of memory, but without uninitialize, no value has been initialized. In this way, this is another form of another example of DUP operator duplicates the value with 5 DUP4 means 5 fours and at 3 locations and duplicating the values. In this way, this is the about duplicate operator, DUP operator. In this way, there are different types of assembler directives, important assembler directives. These are normally not in assembler, which we discussed already. These are DB data byte, these are character strings and numeric strings, L1 DB. In this way, we can define different types of assembler directives. These all are the important assembler directives using 8086 assembly language program, and that need to be executed by assemblers, different types of assemblers like MASM or different types of assembling tools. So the important directives are DUP directive, data definition directive, where we define different types of data like DB for 8-bit data, DW for 16-bit data, DD for 4 bytes of data. In this way, other is starter.exe directive, EQ directive, processor directive, M directive, proc directive, and memory model definition, another important directive, and different types of segment directive, .stack, .data, and .code directives. In this way, these are not compulsory, and we will be using frequently these directives while writing the programs, and other are these optional directives, maybe dosseg, title, or page directive. That's all about the assembler directives, different assembler directives using 8086 and their functions.